Hey everyone, welcome back. Before we blast off to explore one of the solar system's most mind-bending quirks, I'm sending out huge virtual hugs and the very best wishes to all of you watching. Wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy. That's truly the foundation for enjoying the wonders of our universe. Now, buckle up, because we're heading to our scorching, cloudy neighbor, Venus. Often called Earth's sister planet because they're roughly the same size, Venus is actually a hellish world of extremes. But today, we're focusing on something truly bizarre, something that flips our everyday experience completely upside down. A single day on Venus is longer than its entire year. Yeah, you heard that right. Forget 24 hours in a day, 365 days in a year. On Venus, it takes the planet longer to spin around once on its own axis. That's 1 day. Than it takes to complete a full journey around the sun. That's 1 year. It's like if your birthday came around twice before you even finished one full rotation facing your desk at work. It sounds impossible, like cosmic nonsense, but it's 100% true, and it's one of the strangest facts about our solar system. So, let's break down these mind-boggling timescales. First, what exactly do we mean by a day and a year? A year on any planet is the time it takes to complete one full orbit around the sun. For Earth, that's roughly 365 days. Venus orbits much closer to the sun than we do, so its path is shorter. It zips around our star in just 225 Earth days. That means one trip around the sun, one Venusian year, takes less time than it takes Earth to do the same. Now, a day is usually defined as the time it takes for a planet to rotate once on its axis, so that the sun appears to rise, travel across the sky, set, and then rise again in the same spot. This is called a solar day. On Earth, that's 24 hours. Venus, however, spins incredibly, unbelievably slowly. And it spins backwards. While Earth spins counterclockwise, west to east, Venus spins clockwise, east to west. This sluggish, backward spin means it takes Venus a colossal 243 Earth days to complete just one full rotation relative to the distant stars. This is called a sidereal day. But because Venus is also moving in its orbit around the sun while it's slowly spinning, the time from one noon to the next, the actual solar day when the sun returns to the same point in the Venusian sky, works out to be about 117 Earth days. Even this shorter solar day, 117 Earth days, is still significantly longer than the Venusian year, 225 Earth days. So, no matter how you slice it, whether using the full spin relative to stars, 243 days, or the time between sunrises, 117 days, a day on Venus is longer than its year. The sun rises in the west, sets in the east, and you'd celebrate your birthday twice before experiencing a single sunrise to sunrise cycle. Wrap your head around that for a second. Why is Venus such a slowpoke spinner? Why is it doing this weird backward dance? Scientists believe it's likely the result of a colossal cosmic collision billions of years ago, when Venus was young. Imagine another planet-sized object smashing into Venus at just the right angle. The sheer force of such an impact could have literally knocked Venus spinning in the opposite direction and dramatically slowed down its rotation. Think of it like hitting a spinning top sideways with a hammer. It might start wobbling erratically, slow way down, or even reverse its spin direction. Venus essentially got punched so hard in its early history that it never recovered its fast, Earth-like spin. Another factor could be the incredibly thick, heavy atmosphere of Venus. This atmosphere isn't just a wispy layer of gas, it's a superdense, crushing blanket of carbon dioxide with clouds of sulfuric acid, exerting pressure 90 times greater than Earth's atmosphere at sea level. The sheer mass of this atmosphere, combined with powerful winds that whip around the planet much faster than the surface rotates, might create significant friction against the surface, acting like a giant brake, further slowing down Venus's rotation over vast stretches of time. The gravitational tug-of-war, tides, between Venus and the Sun might also play a minor, long-term role in gradually sapping its rotational energy. It's probably a combination of these factors, a primordial knockout blow followed by atmospheric drag that left Venus spinning so incredibly slowly and backwards. Living on Venus would be a truly alien experience, and the day/year paradox would make timekeeping utterly bizarre. Picture standing on the surface, though you couldn't for long without being crushed and melted. The sun would rise in the west, a faint, diffuse glow barely penetrating the planet's thick, toxic, yellowish clouds. Because the rotation is so slow, the sun wouldn't zip across the sky like it does on Earth. It would crawl, painfully slowly. It would take months for the sun to move from the horizon to its highest point at noon. You'd have incredibly long periods of continuous daylight followed by equally long periods of continuous darkness. A single Venusian daylight period, sunrise to sunset, would last roughly 58 Earth days, followed by 58 Earth days of night. Imagine nearly 2 months of constant daylight, then 2 months of pitch-black night. The seasons wouldn't be driven by the planet's tilt, which is very slight, like on Earth, but rather by the incredibly slow progression of the day-night cycle itself. And because the year is shorter than the solar day, the calendar would be chaotic. You'd experience multiple years, multiple trips around the sun within a single Venusian solar day. Celebrating a new year would happen multiple times before you even got halfway through your workday. It completely shatters our intuitive understanding of how time flows on a planet. The strange rotation and the thick atmosphere create equally strange weather patterns. Venus's atmosphere rotates much faster than the planet itself, a phenomenon called superrotation. While the surface might take 243 Earth days to rotate, the upper atmosphere whips around the entire planet in just about 4 Earth days. Imagine hurricane-force winds screaming around the planet high above you, while the ground below crawls along at a snail's pace. These winds can reach speeds of over 360 kilometers per hour, 224 miles per hour, at the cloud tops. The slow rotation also means there are no significant Coriolis forces like we have on Earth. On Earth, the Coriolis effect, caused by our relatively fast rotation, helps spin up large weather systems like hurricanes and dictates global wind patterns. On Venus, with its ultra-slow spin, this effect is negligible. Weather patterns aren't organized into distinct cells driven by rotation. Instead, they're dominated by the planet-wide Hadley circulation. Hot air rises at the equator, flows towards the poles high up, cools, sinks at the poles, and flows back towards the equator near the surface. Combined with the superrotating winds, it creates a chaotic, global blanket of stormy clouds with complex, swirling patterns visible from space, but without the distinct cyclonic storms we recognize. Exploring Venus has been incredibly difficult precisely because of its extreme environment, the crushing pressure, scorching temperatures, hot enough to melt lead. Around 465 degrees Celsius or 870 degrees Fahrenheit, corrosive clouds, and the sheer difficulty of operating on a surface where a day lasts months. Early Soviet Venera landers in the 1960s and 70s managed to send back the first, and so far only, images and data from the surface, but they only survived for minutes before succumbing to the heat and pressure. These brave little robots confirmed the rocky, desert-like surface under the perpetual twilight gloom. Orbiters, like NASA's Magellan in the 1990s, used radar to pierce the thick clouds and map the surface in incredible detail, revealing volcanoes, vast plains, and complex geological features. Missions like ESA's Venus Express and Japan's Akatsuki have studied the atmosphere and its superrotation from orbit. Future missions are being planned to delve deeper into the mysteries of Venus's atmosphere, its geology, and its puzzling history. Understanding why Venus rotates so slowly and backwards is a key scientific question, as it tells us about the chaotic early solar system and the factors that shape how planets evolve. Was it always like this? Did it have water and a faster spin once? Figuring out Venus helps us understand the range of possibilities for planets, including Earth-like worlds around other stars. Venus, with its day longer than its year, stands as a powerful reminder that our solar system is full of astonishing diversity and strangeness. It challenges our Earth-centric view of how planets should behave. It shows us that fundamental concepts like the length of a day or the rhythm of seasons are not universal. They are unique products of a planet size, distance from its star, history of impacts, atmospheric composition, and rotational quirks. Venus is a world where time itself is stretched and warped, where the sun barely moves in the sky for months, where years fly by faster than sunrises, and where the very ground beneath your feet spins in the opposite direction to almost everything else. It's a world sculpted by violence and preserved in a state of extreme, slow-motion intensity. Studying its bizarre rotation isn't just an astronomical curiosity, it's a window into the dynamic and often violent processes that shape planets. It forces us to expand our imagination and appreciate the sheer weirdness and wonder that exists right next door in our cosmic neighborhood. So, the next time you watch a sunrise or feel the rhythm of a 24-hour day, spare a thought for Venus, our backward, slow-spinning, incredibly hot neighbor, where time dances to a completely different, utterly mesmerizing, and profoundly strange beat. It's a humbling lesson that the universe is far more inventive and unexpected than we could ever dream. Thanks for exploring this temporal paradox with me today. Stay curious, stay healthy, and keep looking up and wondering about the weird ones.